Hello dear friends, this is Srinivasan who is having more than 40 years experience in this construction industry, trying to present you a small presentation on the bar bending schedule of the circular column in continuation with my earlier presentation of bar bending schedule for the square columns. Bar bending schedule is a list of reinforcement bars given in an RCC work item presented in a tabular form for each virtual reference. This table summarizes all the needed particulars of the bar, diameter, shape of bending, length of each bend and straight portion, angles of bend, total length of each bar and number of each dia of the bar. This information is a great help in preparing an estimate of quantities. Today we are going to discuss about the circular columns. Bar bending schedule of the circular floor column. BBS of main reinforcement in a circular column. Length of the main bars run parallel with the height of the floor. Length of the main bar is an addition of height of the column, height of the top slab and overlap length which is added at the end of the column for the next floor purposes. Here you can see the main reinforcement has been identified. This is the longitudinal reinforcement which we call as a stirrups. This is the overlap length. Here you can see this longitudinal bar or a ties marked in a red color. Length of each main bar is equal to height of the floor plus height of the slab plus overlap length. Overlap length is equal to 50 dia. Assumed bar sizes. Main bars of 20 mm dia. Dia of longitudinal bars, that is a ties or a stirrups, whatever you can call it as, is 8 mm. Spacing between longitudinal bars is equal to 100 mm center to center. Now you can see length of each main bar is equal to height of the floor plus height of the slab plus overlap length. That is 3 meter, that is the floor height, 0.15 that is the slab thickness plus 50 into 20 mm that is the overlap length makes you total 4.15 running meter. Number of main bars is equal to 8. So total length of the main bar is equal to 8 into 4.15. Now let us come down to 33.2 meter. Number of bars is equal to 33.2 divided by 12. Why I called it a 12? We assumed is a 12 meter long full bar. That's required 2.67 bars. Weight of a steel required is equal to D square by 162. That is 20 square by 162 will make you 2.47 kg per running meter. Total weight of the steel, total length of the main bars into 2.47. That means 33.2 into 2.47 is required 82 kgs. BBS of longitudinal reinforcement in a circular column. Concrete cover deduction. As per concrete cover considering the below circular column, deduct 0.025 mm all sides of the column to find the dimension of the ties. Hence, the dia of the circular stirrup is 950 mm. This will explain you how the things is going to work around. See, here we are having a two bend lengths of 135 degree. This is a 1 and this is 1. Then two hooks. This is a one hook and this is another hook of two hooks. This is the pitch of the dia. It is 950 mm. This is the concrete cover 25 mm. Formula. Total length of each tie is equal to perimeter of the tie, total perimeter of the plus circle, total hook length, or we usually called as a circumferences of a circle is equal to 2 pi r or pi d. Number of ties is equal to floor height divided by spacing plus 1. From the figure, what we learned, dia of the circular die is equal to 950 mm, that is the dia. Number of hooks is equal to 2. Number of bent up of 135 degree is equal to 2. Number of bends bent at 90 degree is equal to 6. So what we got a length is like this. Total hook length will be, hook length is equal to 9 dia. Number of hooks is 2. So total hook length is 9d plus 9d, that is 18 into 0.8 mm is equal to 0.144 mm. Total bend length. Number of a bend of 135 degree is equal to, bend length is 3 dia. Number of bend is into 3d is equal to 2 into 3 into 8, that is a 48 mm. Total bend length is equal to number of bends at 90 degrees 6. Bend length is equal to 2 dia. Number of bend into 3D, total length of 6 into 3 into 8 mm tie will make you 48 perimeter mm of the tie plus total hook length minus total bend length, that is pi d plus 0.144 minus 0.048, that is 3.14 into 95. The 3.14 is equal to pi. This is the dia, plus 144 mm minus 048 makes you 3.079 meter. Number of ties, 3 divided by 0.1 plus 1, that is a 31 ties. So total number of ties is equal to 31 into 3.079, 95.45 running meter. So total number of bars is required, 95.45 divided by 12, that is a 12 meter long bar. We required 7.95 bars. Weight of bars is required, d square divided by 162, that is 8 square by 162 makes you 0.39 kg per running meter. Total weight of the steel is equal to total length of the ties into 0.22, that is 95.45 into 0.39, 37.22 kgs. So we require main bar of 82 kgs and stirrups of 37.22 kgs for one circular column of the described